Hey, 6th grade, how's it going? Mr. Joseph here. Hopefully you guys are doing well. Welcome back to class. Today is either Monday, October 5th or Wednesday, October 7th. It kind of depends on when you're watching this video. It's good to have everyone here. We're going to be continuing with the topic of spatial reasoning, all right? Spatial reasoning is just basically looking at different shapes or figures to understand the world around us. So, welcome back to class. It's good to have you. Again, this topic has to do with lots of different chapters inside of your prime book, both Unit 4 in your book 6A and Unit 8 in your book 6B. Okay, there's actually other chapters that go along with that. I want to congratulate the kids that actually took the quiz for today. Not a lot of kids actually did it. Remember that this resource was inside of the document that I sent you guys. I sent it through WhatsApp, I sent it through Instagram, I also sent it through a couple of your guide teachers. So if you didn't do this yet, you need to make sure that you do it, okay? The link to the video and the link to all the information was there, and only 6 students finished this formative assessment, which was a couple of weeks ago actually, which is kind of sad that only 6 students have finished it. So I do want to congratulate the 6 students that did finish it. Mario, Mariángel Solano, Mariángel, Stephanie, and Carlos. Those are the only 6 students out of group 6A and group 6B as far as right now, October 4th, when I'm doing this video, that have finished this formative assessment. So if you have not done that, boys and girls, you need to do this. Let me show you the link one more time so that you know exactly how to get there. This is a link, and actually it looks like someone's in it right now finishing this. Look at that. We have an anonymous llama finishing it right now. The link that you need to go to, boys and girls, is tinyurl.com/y427MAFC. I actually planned on commenting on a little bit of the content for today, but unfortunately only 6 students have finished that. So we really need to finish that. Remember, what you're going to be doing, boys and girls, is if you want to watch this video, which again is this video right here, okay, it's one of the, looks like 90 students have finished it, or at least watch the video, but they have not finished the survey. So you guys got to watch the video so you can see the questions and then finish that survey, okay? All you do is you just watch the questions. You don't have to finish all 50 questions, okay? Please understand that. There are lots of questions that you can look at, and you don't have to finish all 50. There are a ton of questions here. But please remember, just answer what you know, okay? It gives you, a lot of them just gives you A, B, C, or D. You just read the question, and then you pick A, B, C, or D, okay? I will show you the answers at a later date, but I really want you to finish this. Okay, I think that's the 3rd time I've said it. And it's not that difficult. I mean, just pick A, B, C, or D, or you write your answer here in the blank. And again, these are all the information right here. It's going to be in the video notes for today. I will put all that information in the video notes just so you guys know on the bottom, so you guys can finish that for later on. Okay, I'll stop talking about the formative assessment and get to the class for today. Last time we were able to look at different solid shapes. Mr. Joseph read the book about solid shapes so we could look more specifically of what characteristics they have. So if you didn't check out the video from last time, make sure you check out the video from last time. We talked about different bases and vertices. We talked about comparing different types of shapes, what a face versus a base was. We also talked about some 3-dimensional shapes that don't have bases, right? We have cylinders and cones, which look a whole lot more different than, you know, shapes like a cube or a rectangular prism or things like that, okay? So check out that book if you want to. This was the book that we read last time. It'll give you some vocabulary to use and then also understand this concept a little bit more. So what is your understanding of this topic? Well, you can click on any one of these links. Last time, again, we looked at different vocabulary that dealt with this topic. You can actually go to bestrandoms.com this link right here, which I will also put in the video notes, and you can just update it to see different terminologies, right? We're going to focus today more on three-dimensional shapes than two-dimensional shapes, so things like triangular prisms and other ones. You can actually click the button to find a random bunch of shapes, and it will give you more vocabulary. For example, a cube or a cuboid or a triangular prism. Those are all shapes that are three-dimensional that will get you to understand this topic a little bit more, okay? We have, for example, none of these are three-dimensional, they're all two-dimensional, but you need to know the base of these shapes. For example, a hexagon, in order to understand a hexagonal pyramid or a hexagonal prism. So this is all really, really important vocabulary. So check that out. Let me just update it one more time. Again, this is just random vocabulary that deals with this topic of spatial reasoning. Tells you about the sides, the vertices, whether they're a three-dimensional or two-dimensional shape. Talks about lines and angles, which is a topic that I'm actually teaching 4th and 5th grade in this very week. So check that out. This is kind of a cool resource that I did mention last time. I'm only going to spend a couple of seconds on it, but you can rotate the shape to understand a little bit more about it. So you can check that out on its, you can do it on its x-axis or its y-axis. You can even, understand the shape's sides and vertices a little bit more by generating a new shape. It's kind of a cool resource. You can check that out if you want to. And then move it around kind of however you want to as well. So this is another resource that I kind of found interesting. You can change the way the shape looks by changing this measurement, right? Either the millimeter measurement, you can change it to like 4 or 8 or 16 millimeters. And then you can also add different shapes within the shape to try to understand area a little bit better. So right now I'm actually getting rid of surface area inside of the shape, okay, just kind of like by chipping away at the different cubic units inside of this shape. Okay, you can also, for example, I'm not even really sure what I'm doing, but you can kind of understand the different cubic units, move it around, and see how the shape changes. It's kind of cool. Okay. I'm not even here. Let's move this around over here. Look at that. You can show the shape in different angles, how it's rotating, even the symmetry of the shape. You can compare that if you want to. You can share it later on. It's kind of a neat website, neat resource. This is another website and resource that I thought was really interesting because it shows non-traditional three-dimensional shapes. For example, if I wanted to make an ellipsoid, okay, this is an ellipsoid apparently. You can see it from far or from close up. I can change the longitudinal modifier so that it changes it even more. Look at that. Or I can change the latitudinal modifier. Latitude and longitude are both three-dimensional ways of looking at shapes. We can actually look at the world, our Earth, in a three-dimensional way. And we can also look at the longitudinal and latitudinal specifications of our Earth, right? So isn't that cool? I think it's really neat. We can change the color. We can change the shape settings. Look at that. Like, this is just a really cool website. You could probably spend hours and hours on this. I know I could. You can change the formula. We'll talk a little bit more about area and perimeter later on. But, like, look at that. That's pretty incredible. I would imagine that graphic designers use this type of resource just to kind of see the dimensions of a shape, how it changes in space and time, and etc. So, what we're going to do, boys and girls, is jump over to another resource that I shared with you guys last time. Let me just find it. Okay, this is a paragraph all about the solid shapes chapter inside of your book. These page numbers correspond with book 6A, okay? Not necessarily the workbook, but the textbook. And what we're going to do is we're going to pretend to find the words while we read this paragraph, okay? So you're going to guess which word goes along inside of the blank, okay? So let's read it. This is about solid blank, solid shapes, right? Chapter 4, prime book. Today I'm going to talk about solid shapes. I will discuss 3 separate topics, which are pyramids and prisms, cylinders and cones, and nets. So I broke this up into 3 different paragraphs. You can actually see the indent right here, and then you can also see the title of the essay right here. Okay, so this is the first paragraph. It's called our introduction. So the 3 different topics are pyramids and prisms, cylinders and cones, and nets. These are all having to do with solid shapes, right? We see 3-dimensional solid shapes all around us. I will talk about how they are similar and what? Different, and their distinct characteristics. First, let's talk about prisms and pyramids. A prism is a solid shape with 2 parallel, identical what? Prism. Think of what a prism is. It's a solid with 2 parallel, identical faces. Okay, if you take a look at the prisms that we were looking at from before, I think the vocabulary. All right, this is a prism, for example. We have 2 solid faces, this one and this one on the other side, that are identical. Okay. Some examples of prisms are triangular prisms, pentagonal prisms, and hexagonal prisms. A pentagonal prism, for instance, is a shape that has 5 sides of its base. So that pentagon is the shape that makes the base of the prism. It also has 7 faces, which include 5 sides. So we don't call the actual bases a side, right? We have 2, for example, in this case, with a pentagonal prism, we have 2 bases and 5 sides, which in total cause us to have 7 faces. Okay, take a look at that later on in your investigation. A cross section of the prism is a what? Is cut from the shape, and it's identical, same size and shape of a prism. So let's look at that vocabulary word one more time. If we cut this right here, or right here, or right here, it's going to be identical. Okay. So make sure you guys understand that. It's one of those characteristics of a prism. All right, let me go back to where we were at before. It says that a cross-section of a prism is cut from the shape and is identical in size and shape of a prism. However, pyramids do not have uniform cross-sections. If I cut a hexagonal pyramid, the cross-section will not have the same size, but it keeps its shape. Several students have seen pyramids and other shapes in Mexico and in Egypt. Okay, so make sure you understand the difference between a pyramid and a prism. They are different. Okay, let's go to the next paragraph. It says, second, let's understand cylinders and cones. A cylinder has 2 identical blank flat faces that are parallel and a curved side. What is a cylinder? Well, we remember from cylinders from 2nd, 3rd, 4th, 5th grade, cylinders are identical circular flat faces, right? You have to have that circle in there. Here's an example of a cylinder. Also, a cone has 1 circular flat face or base and a blank surface. Curved surface, just like a cylinder. The cone does not have a uniform cross-section. Both shapes are solids of revolution because each one blank around it. How do you say rotar in English? Revolves around it. Here's an example. So you can see that revolving circular base, right, goes around and around and it doesn't change the shape itself. Let's go to the last paragraph. If you'd like to read this on your own, this is in this tiny URL right here. Okay, so you can check that out. The next says, third, an important topic concerning solid shapes is nets. A net is a figure that can be blank to make a solid. Well, if we look at this net right here, what can we do with this net in order to form the solid? Well, we could cut it and then fold it, right? So I think that, yep, the word is folded. Doblado. Can make a solid. Shiata says a net of a cube has 6 blank. Well, here is a net of what looks like a rectangular prism. It has 6 what? 6 squares. Yep, that's a solid of a cube, right? Fabian says if you unfold a cubic box and lay it flat, you will get a net of a cube. Ali says a net of the cuboid will also have 6 rectangles. A net of a blank prism looks like this. What is this again? This is a pentagonal. Nope, this is not a pentagonal prism. Ah, yes, it is. Okay, here we go. Here's the pentagon, which is the base, because there are 2 pentagons and 4 rectangles in the figure. Here are 2 pentagon bases, and then our 4 rectangular sides. In conclusion, we learned about solid blank, solid shapes, specifically about prisms and pyramids, as well as cylinders, cones, and lastly about what? What was that last paragraph we just talked about? Nets. In addition to learning about the blank of solid shapes, we also learned that writing a 5-paragraph essay can be difficult, but we finished. Yeah, so we learned about the characteristics of those solid shapes. All right, let's dive in a little bit deeper about those solid shapes and also understand a couple of more interesting aspects of this chapter, spatial reasoning. Okay, what we're going to do today, boys and girls, is we're going to talk a little bit about the characteristics of certain shapes. Okay, we can find that certain shapes are symmetrical. Well, what does that mean? If we look at the lines of symmetry, it means we can cut those shapes into a section and it's going to equal the same shape on the other side. Okay, so if we make some examples of some symmetrical things in real life, we could say a banana is symmetrical. We could say that a chair is symmetrical. We could say a bed is symmetrical, right? We're cutting those in half. Now, if we cut this tree, for example, in half, this side is going to be the same side as this side. That's called symmetrical. But if we cut this tree in half, this side is not the same as this one. That is asymmetrical. In other words, it's not symmetrical. So take a look at these shapes right here. Focus on the ways that these shapes are cut. Okay, they have either 2 or 4 or 0 lines of symmetry based on how you can cut them. Okay, each one of these shapes, boys and girls, either has 0, 1, 2, 3, or 4 or more lines of symmetry based on how you cut them. For example, this isosceles triangle here in the corner, you can cut it down the middle and you'll have 2 separate sides that are the same. But if you cut it right here down the middle, right, horizontally, it's not going to create a line of symmetry because this part up here is not going to be the same as this part down here. There's also different types of symmetry. We could talk about reflectional symmetry, which means that one side reflects the other side. If you look at a mirror, that's an example of reflectional symmetry. We can also talk about translational symmetry. In other words, it's the same message, just like in a language, right? But it's just been pushed to a different part of the plane, right? So for example, with this one, this letter A is the same as this one over here, but it's been translated over to a different part of the plane. Here's another example with the triangles. This triangle and this one, they're all the same, but they're just moving across the plane. That's called translational symmetry. And then we have rotational symmetry, which is basically meaning that the shape is not changing at all whatsoever, okay? Like this one didn't really change either. However, you are rotating it just like a clock, okay? So if you look at this example, you can rotate this once, twice, 3 times, and this little yellow ball is going around the shape. That's called rotational symmetry, okay? So for example, this part right here could rotate to another area of the plane, and it would still say the same shape, but it's just rotating around, okay? Now, just like I showed you guys with this, we can rotate the shape. Where is the example? Right here. We can rotate it around just like this. Okay. I think it's also important that we understand that I have so many things open that I can't find where we were at. Give me a second. Where are we at? Oh boy, I lost my spot. Oh my goodness. Oh, give me a second. Where were we? Oh yeah, we're right here. I opened it up in the beginning. We can rotate different polyhedrons. Now, what is a polyhedron? A polyhedron is broken up into two different parts. Okay, so a polyhedron in geometry is a three-dimensional shape with flat polygonal faces, straight edges, sharp corners, or vertices. The word polyhedron comes from the classic Greek or griego, which means poly or stem or many, and hedron, which means base or seat. In other words, this polyhedron right here has many bases or many seats that it can be used to classify. Now, there are tons of different types of polyhedrons. Okay, in other words, polygon. It's another word for polygon. We have cubes. We have prisms. We have different types of prisms. So we have pentagonal prisms, we have hexagonal prisms, we have also pyramids, so triangular pyramids, or different types of the base with the pyramid, right? There's tons of these polyhedrons, okay? Recognizing them is really important. So go back to these resources right here so that you can understand the different types of polygons, okay? I think this resource was really great when it came up with different types of polygons. So right here here's a polygon. This pyramid is a triangular pyramid, that's a polygon, but right here, this is not a polygon, okay, because it does not have any vertices. It's a two-dimensional shape. So make sure you understand that. So why is this important? Well, later on, you guys are going to be learning a little bit about area and perimeter. Okay, we've already learned about that in 4th and 5th grade, but in 6th grade, you get to measure area and perimeter a little bit more. Remember the different formulas of area and perimeter. Perimeter is the distance all the way around, okay? And area is the amount of space that's inside of the figure. So if we look at this shape right here, we could count the perimeter with 6 plus 3 plus 6 plus 3 and find out that would be 18 cubic units. Whereas the units change a little bit in area, right? We have to take the width times the height, okay? So for example, this would be 5 centimeters times 2 centimeters, which equals 10 centimeters, okay? Or 10 units squared. You can see that right here on the board, all right? Area and perimeter are very, very important concepts when looking at spatial reasoning, okay? There's also a very important concept when we're looking at spatial reasoning, when we're taking a look at solid shapes that are not typically quadrilaterals, okay? So for example, we have a circle, which is not a quadrilateral. We have a triangle, which is not a quadrilateral. And the areas of those shapes are going to look a little bit different, okay? This area, for example, of a triangle is going to be the same as a square, but now we're going to be dividing it by 2 because technically a triangle is a square that's been kind of cut in half and sectioned off a little bit different. Also, the area of a circle, which we've already looked at this year, is different because we take pi, which is the relationship that we have with the perimeter and a circular shape, times the radius, which is half the shape, squared. Okay, so we're taking that radius squared, and then we're going to multiply that by pi. Okay. Estoy grabando un video, un momento. Okay, sorry about that. So the last thing that I want to show you guys, boys and girls, is the different resources that you can use, like BrainPop and other resources that you can use for this investigation. Okay, so I will put all those resources inside of the video notes on the bottom. And thank you for your attention. I appreciate it. We will talk to you guys later.